Hi and Assalamualaikum. In this video, we are going to present our project 2, and that is design of single phase 202 permanent magnets furnace module. We are from Group 7. My name is Muhammad Khairul Zari, and my partner is Muhammad Ali bin Mazmi. So, this is our power parameter, and then the question asks to explain the step-by-step process of design through video recording. So, now I will explain on how to design for this project. First thing we need to do is we click file and we choose new, and then we create a geometry, and after that we can rename it. In this case we are from group 7, and then I name it as group 7. And then after that we have to click the create 2D sketch, and then we right click and we rename it. The first thing is water, and we choose any color that we want. After that we click the circle. And in this case, our circle radius is 18.5 millimeter, which is our shaft radius. And then we add another circle. So for this circle radius is 75.85 millimeter. And then we click the line and we add to line. After that, we click the sketch trim and we trim the part that we did not use it. After that, we add another circle. So for this circle radius is 51.8 millimeter. And then we add another line and we press Ctrl on the keyboard and we click this line and we change the distance to this line, and the distance is 18.5 millimeter. After that, we trim the part that we did not use it. And next is we select all the object and then we create region and we click apply and close. After that, we click the object and we duplicate the object and we click the edge and we click the region, merge region. And we have to do the same step. We duplicate the object, we click the edge and merge regions. So that's all for the router part. Then for second part is we create a permanent magnet, and then we choose any color that we want. After that we add a circle. So for this circle is to be same as previous, which is 75.85 millimeter. So as you can see here, the circle same as the previous circle. So after that, we add another circle, which is our outer radius circle is 88.8 millimeter. And then we click OK, and we add two line. So after that, we have to do the same thing, which is we change the distance between these two lines, which is 18.5 millimeter. And we trim the part that we did not want, we did not use it. After that, we click the object, select the object, and then we create the gem, and we apply and close. After that, we duplicate the object, which is the region minimum copy, and we select the edge and merge regions. So after that, we do the same thing, but in this case, we select the y-axis, and then we don't want it to become one solid, so we did not click the merge regions. So that's all for the for permanent widget. And now we move to the third part, which is for the static part, and we rename it and we choose the color that we want. After that, we add the circle. So for this circle is inner radius, which is our parameter is 103.6 millimeter. Then we add another circle. So this is for the outer radius, which is 166.5 millimeter. And the last one we add another circle. So for this circle is 148 millimeter. And we zoom out a little bit. So we add a line. And we do the same things, which is we click on these two lines and we change the distance between this line, which is 18.5 millimeter. And then we trim the pathway that we use. After that, we select the object and then we create regions, and then we apply and close. So we do the same thing, which is we create a region, and then we duplicate the object, and then we click the edge and we merge the regions. So that's all for the center part. Now we move to the last part, which is entry point. So this is for the last part is for the entry point. So we do the same thing, we rename it, and then we choose any value that we want. After that, we add the sticker. So for the sticker, radius is 148 millimeter, and we add another sticker. So for the sticker, which is in radius, the value is 103.6 millimeter. And then after that, we add the line. And then we do something, which is change the distance, and that is 18.5 millimeter. And as usual, we trim the part that we did not see. After that, we select the object, and then we click the chance, and then we apply, and so this is the different one, which is we just only mirror the object, but we didn't match the regions because the file is a different part. And then, as you can see here, we are done for the first part. So I think that's all for the part one.
Assalamualaikum. My name is Muhammad Alif bin Azmi. and my metric number is CE200042. So I will continue for the part 2. So first of all, we need to click on the two model and select the transient analysis, and then we need to insert all of the material and condition to this model. So first, we need to find the for the stator and rotor for 335H210, and then we drag into the stator and click OK. Also for the rotor and click OK, and then we need to find the magnet, which is Neomax 35VH. We click on the erasable and drag the material into the magnet for both magnet, and then we click OK. For the coil material, which is the conductor copper, and then we drag to all of the coil and click OK. And then next, we need to create a skirt. We click on the magnetic transient and add a skirt. We put the coil at the ground and we connect all of the components. So for the coil turn is we're going to use 10, and also for the second coil is 10, and we just close the skirt. It will already save. And then for the condition, we need to click on the rotation, drag on the rotation into the rotor. Also for the magnet, because it was rotating as well, and the speed is 44440 rotation per minute. And we click OK, and we add all the force for the rotor and also for the magnet, and we click OK, and we insert the FEM code. And for the both side, we need to choose the downward and click OK. And the second one for the downward. For the downside, we need to click on the upward. Also for the another one, and click OK. Next, we need to click on the study magnet and click on the properties. And the step is 37, and the type is regular interval, and the time which is 0.05, and division is 36. We go to conversion, and the stack length is 25 millimeter, and we click OK. So the next part, we need to connect the coil. So the coil, this one we can delete, and then this one click edit and add coil, and we need to connect the up coil and the down coil. So click OK, and then for another side also add second coil and connect the coil. So on here already connected for the upward and downward coil. So next we need go to mesh, add part, and select all the part, and we click OK. Then click mesh once again and go to the properties, click on the slide mesh, and then we can generate. So we close this one, and then we go to the magnet and run activity case. So it will running. So on here we can see the result from the graph. So the result, so we can see all the result. For example, we want to see the circuit electric power. So this is the result for circuit electric power, and we can see also the coil plug leakage. So this is the coil flux leakage for the 10 turn. So for the next part, we want to see the turn for 20 turn. We just go to the the circuit. We go to the circuit and we view the circuit. Oh, we change to the circuit into 20 turn, and also for the second one 20 turn, and then we close, and then we can run. Okay, this is the coil plug leakage for the 220 turn. We also can see the result for this one. You can see the magnetic flow, the magnetic flow from this is the 27 step. So I think that's all from me. Thank you.
So now we move to the 3D part, which is we extend the model to the 3D, and then we just click OK. And we wait a little bit. So as we can see here, the model in 3D. Firstly, we do the symmetry boundary. So we select the front side, select the front object, and we repeat the same thing. We do at the back side. And we click OK. So after that, we do the part for the mesh. First thing we do is we change the properties for the mesh, and then we change the model line to 1.05, and we click the extruded mesh. So next is we add the size control for the part, which is for the splitter. Click OK, and we do the same thing for the outer part. Then we click the mesh and we add the size control for the base. So basically, this already shown in the instruction. So we just do it. So after we finish, we do the rotation preloaded mesh, which is we set to automatic. We rename it to automatic. And we delete the part that we don't use it. After that, we generate the mesh. So after done it, we click the study and we click the properties and we change the number stack, the enzyme and division based on the instruction given. After that, we pick the study and we run active case, and then we wait for the result. So after done it, we just click close. Then we found the result and graph, and we click the top and show the result. This is our top graph. Then we do the for coil plug linkage. So this is the graph for the coil plug linkage. And the last thing we do for the FDM coil inductance. So this is for the result for the FDM coil inductance. So I think that's all for the 3D part. Thank you.